Hi everyone, my name is Shreyam Bhattacharya. I'm a lecturer at Agora Math Circle, and I'll be reviewing the Math Kangaroo 2023 for grades 9 and 10. Question number 1 states that a gray circle with 2 holes is put on top of a locker face as shown. The gray circle is turned around the center so that the number 10 appears in one hole. Which numbers is it possible to see in the other hole? So to approach this problem, you're already given a diagram over here, and then so you can tell that there's 1 here and 5 here. So you can assume that there's 2, 3, and 4 in between, 1 and 5. So because you know that there are 3 numbers in between each, and you know that 10 appears in one hole, you can start at 10. Then 3 numbers away is 1, 2, 3. So the other number is 2. But that's only if you go to the right. If you go to the left, let's say, then 3 numbers in between would mean 9, 8, 7, which means the other number would be 6. So the answer is A, 2 and 6. Question number 2. Katie had to run to catch the subway, got off 2 stops later, and then walked to school. Which of the following speed time graphs would best represent her journey? So because you can sort of separate this into 4 parts, which is her walking part when she's on the subway, she's on the subway twice, and then the part where the running part where she's on the subway, and then the walking part. So because there are 4 parts, you can first look for the graphs with 4. So you know this is 1 and this is 1. So it's between B and D. So when you run, it's normally, let's say it's the speed, and when you run, it's normally slower than when you're on the subway. So we can say that the subway, your velocity is about this much. And then when you walk, it's going to be slower than both when you are on the subway and when you run. So let's say your walking is about this much velocity. So which graph is similar to this? And as you can see, it is D, this graph. Question number 3 states the positive integers m and n are both odd. Which of the following integers is also odd? So to approach this problem, you can just assume of any 2 odd integers. Let's say m is equal to 3 and n is equal to 5. So now let's try each of these. So if we take a, then m, which is 3 times n plus 1, which is 5 plus 1, is equal to 3 times 6, which is 18. If we take b, this is m plus 1, so 3 plus 1, times n plus 1, which is 5 plus 1. This is equal to, so 3 plus 1 is 4, 5 plus 1 is 6, so 4 times 6 is 24. As you can see, none of these till now are odd, they're both even. Let's take C. So m plus n plus 2. So m is 3 plus n, which is 5, plus 2. So this is equal to 3 plus 5, 8, plus 2, 10. Now let's take D. So m times n plus 2. So m times n plus 2. As you can see, for this one you have to follow order of operations. So first you do multiplication, and then you do addition. So this is 3 times 5, which is 15, plus 2, which is 17. So this is an odd number, but just in case, let's try E. So m is 3 plus n, which is 5, is equal to 8. So as you can see, but all a, b, c, and e are even integers, while d is the only odd integer, which means the answer is D. Okay, so question number 4 says a large square of side length 10 centimeters. So let's say here we can put 10 centimeters. Contains a smaller square of side length 4 centimeters. So we can say this over here is 4, as shown in the diagram. The corresponding sides of the two squares are parallel. What percentage of the area square of the large square is shaded? So first, we know that it's a square, the big square, and its side length is 10. So let's say total area of the big square is equal to 10 times 10, which is equal to 100 centimeters squared. Now, let's try finding the area of one shaded region. So because the smaller square is directly in the center of the larger square, you know that this length and this length are equal because it's symmetrical. So let's say, 10 minus 4 is 6, which means each side has to add up to 6. So 2 times, let's say this is x, 2 times x equals 6, which means x equals 3. So each of these length over here is 3. So, it'll be better if we show it here. So this length down here is 3. So now we know this base over here, this base over here, and the height. So the area of a trapezoid, area of trapezoid is equal to 1/2 times the, if you add both the bases, so 4 plus 10, times the height, and the height is 3. And this leaves you with 14 times divided by 2, so 7 times 3, 21. But because we have two shaded regions, we have to multiply this times 2, which is equal to 42 centimeters squared. So it asks for what percentage. So let's take 42 divided by 100, which is equal to 42%. So the answer is D. So question number 5 states that today is Thursday. What day will it be in 2023 days time? So 2023 days time. So to approach this problem, we know that there are 7 days in in 1 week. So then let's see how many weeks it will be. So if we divide 2023 days divided by 7 days in 1 week, we'll get 2, 6, this should be 8, 6, 9. So this is equal to 289 weeks. So as you can see, it's 289 perfect weeks, which means that there's no remainder. So because today is Thursday, we'll end 289 weeks later, which is also going to be Thursday. So the answer is C. So question number 6 states, the large rectangle in the diagram is divided into 30 equal squares, as shown. The perimeter of the shaded region is 240 centimeters. What is the area of the rectangle? So because we know that there are 30 equal squares, we can set up 30 times x, which is the number of squares, or the length of each square, is equal to 240. So x, we can say, is 8. So each of these squares is 8. And now let's find how many squares are in the length and width. So let's say length is 1, 2, 3, 4, 5. So it's 5 squares times 8 centimeters per square, which is 40 centimeters total. Then the width is equal to 1, 2, 3, 4, 5, 6. So it's 6 times 8, which is equal to 48. Now let's multiply these two values. So 48 times 4, and then we can multiply 10 afterwards. So 48 times 4 is 32, 16, 192. Then because it was 40 and not 4, then we can add a 0, and it's 1,920 centimeters, which means the answer is D. Question number 7 is that the ages of a family of 5 add to 80. The two youngest are 6 and 8. What was the sum of the ages of the family 7 years ago? So we have the ages of 2 family members, but not the other 3. So let's just write them out as 6, 8, and let's say x, y, and z. So we know that 6 plus 8 plus x plus y plus z is equal to 80. Now let's see what it is 7 years ago. So let's do minus 7 to each of these. This is -1, this is 1, this is x minus 7, y minus 7, and z minus 7. So because you can't be a negative age, we just cross this one out. So we can just assume this is 0. So now we have to find that 0 plus 1 plus x minus 7 plus y minus 7 plus z minus 7 is equal to, let's say the age is a. So now let's combine all of the constants. So we have x plus y plus z, and then we have 1 minus 7 3 times. So this is minus 21 plus 1, which is minus 20, is equal to a. Now we have two of these different equations. We have this one and this one. Let's rewrite this one. So let's bring both of these constants to the other side. So let's say x plus y plus z is equal to 80 minus 6 minus 8, which is equal to 80 minus 14, which is 64. Or, sorry, not 64, 66. So now we have x plus y plus z is equal to 66, and we have x plus y plus z here. So let's just substitute it in. So 66 minus 20 is equal to a, which means 46 is equal to a. So the answer is D. So number 8. A wooden fence consists of a series of vertical planks, each joined to the next post by 4 horizontal planks. The first and last plank in the fence are vertical. Which of the following could be the total number of planks in the fence? So to approach this problem, let's draw a simple diagram. So it consists of vertical planks, each joined to the next by 4 horizontal planks. So let's say it's 2 vertical planks, each joined by 4 horizontal. So 1, 2, 3, let's make this a little bit longer, and 4. So we can say that there's 6 planks in one of these fence posts. So, and since the first and last plank in the fence are vertical, as it states in the problem here, we know that the total number of planks must be divisible by 6. So let's test each of these. So 95 divided by 6 is 1, 3, oh, it's not divisible. So you get 15, remainder 5. Let's try B. So this was A, let's try B. 96 divided by 6. You have 1, 36, 6. Oh, so this is divisible by 6. Let's try C. 97 by 6. 1, 3, 6, remainder 1. And you can do D and E, and you'll get that it's 16, remainder 2, and 16, remainder 3, respectively. So the only one that is truly divisible by 6 is 96. So the answer is B. Question number 9. The letters A and B are to be replaced by positive integers so that the equation is correct. In how many different ways can this be done? So let's rearrange this. We have this equation on the right over here. Let's rearrange it. So let's say A is equal to 35 divided by B. So with this equation, let's test certain values. So we know that they're both positive integers, A and B, which means that which value 35 divided by something gives a positive integer. So that means B must be equal to 1, 5, 7, or 35. So this means that there are 4 possible combinations. So the answer is E. Number 10. After having played 200 games of chess, my winning rate is exactly 49%. What is the smallest number of extra games I need to play to increase my winning rate to exactly 50%? So let's say the winning rate is the number of sorry, let's erase that. The number of wins, W, divided by the 200 total games that have been played. So this is equal to 49% or 0.49. Now we can calculate the number of wins. So W is equal to 0.49 times 200, which is equal to 98. So there are 98 wins. So let's say that you then have to play a number of games G. So these number of games, G, plus the 98 wins you already have, divided by G plus the 200 games you already played. We're assuming that you win all of these G number of games you are going to play. Assuming you win all of them, they have to be equal to 0.5 or 50%. So now let's cross multiply. So G plus 98 is equal to 0.5 G plus 100. Now if you rearrange it, you get 0.5 G is equal to 2, which means G, well, you can also rewrite this as half G is equal to 2, which means G is equal to 4. So the answer is E, which is 4. So this is question number 11, and as you can see, the problems are each worth 4 points. So questions number 11 through 20, so 11 through 20 are worth 4 points each. So let's read the question. Julia is trying to save water. She reduced the time spent in the shower by a quarter. She also lowered the water pressure of her shower to reduce the rate at which the water comes out of the shower head by a quarter. By what fraction did Julia reduce the total amount of water she uses for a shower? So let's say that the total time she spent on the shower was 1. So she reduced it by a quarter, so you can subtract a quarter, which is 1/4, and you get 3/4. And let's say this is the time in the shower. Now let's look at the water pressure. So the pressure. Let's say that is also starts at 1, and she reduces this also by a quarter, so minus 1/4, which is equal to 3/4. Now, if we multiply these two values, you get 3/4 times 3/4, which is equal to 9/16. So this value, 9/16, this isn't the answer, but it means that she's spending 9/16 of the original time that she used to spend in the shower. So we can assume that her original time was 1. Let's subtract 9/16, and we are left with 7/16, which means the answer is E. Question number 12. The diagram shows 3 squares of side length 3 centimeters, 5 centimeters, and 8 centimeters. What is the area in centimeters squared of the shaded trapezoid? So here we can sort of see 3 different similar triangles. Let me outline them in different colors. So 1, 2, and 3. It's not perfect, but it'll do. Now let's try just drawing them over here. So there's 1, which is side length of x, and we know that it's part of a square. So here it's 3, here it's 5, and here it's 8. So we know that here is 3. For the next triangle, which is a bit bigger, let's say the side length here is y, and the base is going to be 3 plus 5, which is 8. And then for the final triangle, the side length, as we can see over here, the side length is 8, and the base is 3 plus 5 plus 8, which is 16. So now we can sort of set up some proportions. So we can say that x by 3 is equal to y by 8, which is equal to 8 by 16. So this essentially means that x by 3 is equal to 8 by 16, which means that x is equal to 24 by 16, which is equal to 3 by 2. And also y by 8 is equal to 8 by 16, And this means that y is equal to 64 by 16, which is equal to 4. So we can say x is equal to 3 by 2, and y is equal to 4. So now we have to find this shaded area over here. Let me erase the marks that I made here. So as you can see, the shaded area is a trapezoid. And since we know x and y, x is here, y is here, we know that this side over here is 3 by 2, this side over here is 4. And we also know the base, which is 5. Or technically in this case it would be the height. So now we can use our area of the trapezoid formula, which is equal to 1/2 times the height, which is 5, times the bases added together. So 3 by 2 plus 4. So now this is equal to 5 by 2 times, so 4 can be rewritten as 8 by 2, so this times 11 by 2, was equal to 55 by 4. In other words, the answer is B. Question 13. A wire of length 95 meters is cut into 3 pieces such that the length of each piece is 50% more than the previous piece. What is the length of the largest piece? So let's say that the length of the original shortened piece is x. And okay, let's just say the first piece is x, second piece is y, third piece is z. So it says the second piece is 50% more than the previous piece. So let's say x is just equal to some length L, and y is equal to 1.5 times, or 50% more than L. So it's 1.5 L. And z is 50% more than y. So it's 1.5 y, which is equal to 1.5 times 1.5 L, which is equal to 2.25 L. So now we know that L plus 1.5 L plus 2.25 L is equal to 95. Now we can add all of these together to get 3.75 or 4.75. L is equal to 95. So then if you divide this, you get a value of L equals 20. I won't do the division here, but this should be what you get. And now it asks for the length of the largest piece. And we know the largest piece is this one right here, 2.25 L. So 2.25 times L, which is 20, is equal to 45 meters. In other words, the answer is C. Question number 14. Points M and N are the midpoints of two sides of the rectangle. What fraction of the area of the rectangle is shaded? So they haven't really given you much information on this question. But we can try rewriting this to make it easier. Let's try redrawing the diagram. So let's say that let's make this a little bit longer over here. So let's say this is M and this is L, or M and N, sorry. Let's try reflecting each of these parts on the bottom. Let's try reflecting them to the top part over here. So what you'll find is that the diagram will look something sort of like this. Sorry, it's not a very good diagram, but it'll do. And ideally, what you would see, because each of these hits the bottom and each of these hits the top, is that they're all the same height. So let's call this point over here, let's say this is some point h, some height. And so you can see that there is no blank empty space in this section over here. So this whole section, this whole base is MN. And because each triangle hits the height over here, we can call this height H. So we know that half times the base, which is MN, times the height is equal to the area taken up by the triangles. But we also know that 2 times mn times h is equal to, well, this is the area of the triangles, is equal to the area of the square. 2 times mn times h is the area of the square, because the square, or I'm sorry, the rectangle, because the rectangle is this whole section over here. That is 2h, because there's also h over here, times mn. So, because this mn and h are both constant between the area of the triangle and area of the square, we can sort of find the fraction of the shaded region. So the fraction would be area of the triangle divided by area of the square, which is equal to 1/2 divided by 2, which is equal to 1/4. So the answer is C. Question number 15. Pentagon ABCDE is divided into 4 triangles with equal perimeter. Triangle ABC is equilateral, and AEF, DFE, and CDF are 3 identical isosceles triangles. What is the ratio of the perimeter of the pentagon ABCDE to the perimeter of triangle ABC? So this is a little bit confusing at first, but let's assign some variables. Let's say that this because this triangle ABC, because this is a equilateral triangle, we know that the side lengths A to C, B to C, and A to B, or B to A, same thing, are all equal length. So let's assign them the variable 2a, just so it'll be easier later. So 2a to each of these sides. Now, as we can see, A to C, this length over here, line AC, is split into 2 bases of each triangle. So we can say this base is A, this base is A. And because each one has the same perimeter, we know that this side must be 5 by 2a, and this side must be 5 by 2a. And we can also say that this side AD or ED is just A. So now if we add everything up and find the area of the trapezoid, we get, or sorry, not area, perimeter of the trapezoid, we get 2a plus 2a, we get this 2a plus this 2a plus this 5 by 2a plus this a plus this 5 by 2a. And this is equal to so this will be 4, 5, 9, 10. This should be 10a. So the perimeter of the trapezoid is 10a. Now let's find the perimeter of triangle ABC. So perimeter of ABC. This is equal to just 2a plus 2a plus 2a, which is equal to 6a. Now what is the ratio of the perimeter of the pentagon? So the perimeter of the pentagon, what is the ratio of that to the ratio of the triangle ABC? So that is 10a over 6a, which is equal to 5 by 3, which means the answer is D. Question number 16. On the table, there's a tower made of blocks, numbered from 1 to 90. Bob takes blocks from the top of the tower, 3 at a time, to build a new tower, as shown. When he has finished building the new tower, how many blocks will be between the blocks numbered 39 and 40? So let's say Bob takes a block n. Then the blocks he will take along with it will be n minus 1 and n minus 2. So this means we can say that n is divisible by 3. So let's try to find a number between or around 39 and 40 that is divisible by 3. Well, lucky for us, 39 is divisible by 3. So according to this structure, Bob will be taking blocks 39, 38, and 37 all at once. So after the 37, 38, and 39 blocks, Bob, as we can see from this diagram over here, will go to 3 less than the original one, which means that the next one will be 36. However, we're not considered, or we don't need to know what is after this because 36 isn't what we need to know. We need to know where 40 is. So let's try going backwards. This means that if we go backwards, then as we can see here, this is 90 over here is 5 more than 85. So 5 more than the previous one would be 42. And this means 41 and 40. So these would be the blocks underneath it. So now we have between 40 and 39. Between 40 and 39, there's 1, 2, 3, 4 blocks, which means the answer is E. Number 17. Every third step of a staircase with 2023 steps is colored black. The first 7 steps are shown in the diagram. Anita walks up the steps one at a time, starting with either her right or left foot, alternating each step. What is the smallest number of black steps she will step on with her right foot? So let's say here she starts with her left foot. Then it'll be left, right, left, right, left, right, left, right. So we can see that first for the first black step is on her left, the second is on her right. If you continue this pattern, the next black step up here will also be on her left. So we can say that every second black step or every other black step is with her left foot, and consequently every other step is going to be with her right foot. So let's find the number of black steps that she steps on with both feet. So 2023 steps total, and we know that there are black steps every 3 steps, so we can divide it by 3. So then when we do this, we get 6, 2, 7, 1, 4. So set and remainder 1. So we had 674 remainder 1. We can assume that this remainder 1 will be a white step, so we're only concerned with the 674. So we have 674 steps that are black, and now we have to find how many she steps with her right foot. Because she steps with her right foot on half of this, because she steps with her right foot the same as the number she steps with her left foot, we can divide this by 2, in which we get 3, 3, 7. So 337 or D. Question number 18. We call a 2-digit number powerless if none of its digits can be written as an integer to a power greater than 1. For example, 53 is powerless, but 54 is not powerless, since 4 equals 2 squared. Which of the following is a common divisor of the smallest and the largest powerless numbers? So let's try finding the largest and smallest. So if we look for the smallest, we can say that it has to be a two-digit number, and it can't be 1 because 1 to any power, 1 to the power 1, or 1 squared, or 1 to the power 3, it's all equal to 1. So 1 is at like something such as like 11 or maybe even 15 will not be powerless. So let's try finding something different. Let's try 2. So 2, oh, well, 2 to the power 1 is going to be equal to 2, and that's it. Nothing to a power greater than 1 is equal to 2. So we can say that the smallest powerless number is 22, because none of these digits are, if you square a number, you never get 22, or you never get 2. Now let's try finding the largest. So similarly, let's first list out the digits where if you square them, then, or you can't get those digits by squaring them. So 2, so let's list out the digits. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I guess we can put 0. So 1, we said 1 to the power anything, is going to be 1, so this gets ruled out. 2 works, 3 would work, 4 would not work because 2 squared is equal to 4, 5 would work, 6 would also work, 7 would work, 8 would not work because 8 is equal to 2 to the power 3, or 2 cubed, so 8 would not work, and 9 is equal to 3 squared, so 9 would not work. So the greatest number here is 7. So we can say that the largest powerless number would be 77. And because we have 22 and 77, we know that a common divisor is 11, or D. Number 19. A square of side 30 centimeters is divided into 9 identical smaller squares. The largest square contains 3 circles with radii 5 centimeters, the bottom right. So we can say that this is radii 5. 4 centimeters top left, so we can say this is 4. And 3 centimeters top right, so we can say that this is 3. As shown, what is the area of the shaded part? So let's try finding the areas of the circles. So we have pi times 4 squared, which is the area of the top left. So let's say top left. And then let's say top right is pi times 3 squared. And then bottom right is pi times 5 squared. So as you can see, you get this equal to 16 pi, this equal to 9 pi, this equal to 25 pi. We can see that the two shaded ones, both of these, top right, top left, both of these add up to 25 pi. So 16 pi plus 9 pi is equal to 25 pi. So essentially, the areas, or the areas within these circles are negligible, which means that all we have to do is be concerned with the shaded region itself. So all we need to do is be concerned with this shaded area. And we can assume that this part is filled in because each of these is equal to this. So this is 5, 1, 2, 3, 4, 5 different, let's say, squares that are shaded. And what is the area of the shaded part? So each square is 30 centimeters, or sorry, this whole square is 30 centimeters. So we know that this entire length is 30, which means that we can say that the length of each one is 10 because it's divided into 3 on each side. So because each one is 10, we know that the area of each one is 100. And because we have 5 of these, the total area is equal to 5 times 100 is equal to 500 centimeters squared, which is B. Question number 20. Tim calculates the mean of 5 different prime numbers. His answer is an integer. What is the smallest possible integer he could have obtained? So when we add the 5 different prime numbers, his answer must be an integer or a multiple of 5. So let's look at the first 5 prime numbers because we also have to find the smallest possible integer. So let's check the first 5 prime numbers. So we have 1 plus 3, or sorry, 1 isn't prime, so 2 plus 3 plus 5 plus 7 plus 11. This gets us to 28. But 28 is not divisible by 5, so let's check the next ones. Let's start with 2 plus 3 plus 5 plus 7 plus 13 instead of 11. And here we see that we get an answer of 30. And 30 is divisible by 5, and 30 divided by 4 is equal to 6. So our answer is C. So this is question 21. You can see that it says 5 points each because questions 21 to 30 are the most difficult and are worth the most points, which are 5 points. So let's look at the question. The diagram shows two touching semicircles of radius 1 and parallel diameters AB and CD. What is the square of the distance AD? So, this question, again, is one of the harder problems, but let's try to break it down. So first, let's try finding the components of this triangle between both the centers of each semicircle. So because from this center here to this point out here is the radius of 1, and it's again to the next one, we can say this total distance is 2 because each radius is 1, and if you add them together, it's 2. Now this length over here is 1 because it's the radius of one of the semicircles. So now we can find, let's say this is point, let's say it's point E and point F over here. So now we can say that, now we can use Pythagorean theorem to say that EF squared plus 1 squared is equal to 2 squared. So EF is equal to square root of 3. So now we know that this length over here is equal to square root of 3. So now let's try to find the bigger triangle. So we can draw a line going down like this, and we know that this length, let's erase all of this over here. We know that this length is 1 because it's the radius of one of the semicircles. And we know that this length between both the midpoints is square root of 3. And because we know that this is 1, we can also say that there's 1 here. So this total length, from this point A to this point over here, let's say this is point Z, this whole length, AZ, is equal to square root of 3 plus 2, that whole length. And we know that DZ, this length over here, is equal to 1. So now we can find the length of AD using Pythagorean theorem again. So AD squared is equal to 1 squared plus square root of 3 plus 2, the whole squared. So if we expand this out, we get AD squared is equal to 1 plus 3 plus 4 root 3 plus 4. So AD squared is equal to 8 plus 4 root 3. And again, it asks for the square of the distance of AD, which means the answer is B. Question 22. When it is given a list of 4 numbers, the Kangaroo machine continues the list by typing the smallest non-negative integer that is different from each of the 4 preceding terms and then repeats this process over and over again. Jacob types the numbers 2023 into the machine. What number will be the 2023rd in the list? So let's type out the sequence, or write out the sequence. 2, 0, 2, 3, then it should be 1, 4, 0, 2, 3, 1, 4, 0, and etc. So as you can see, when after disregarding this first term, we have a 5-digit sequence, which consists of 0, 2, 3, 1, 4, 0, 2, 3, 1, 4, 0, and etc. So what number will be 2023rd on the list? So the 2023rd number on the list means that it has to be the 2022nd number in the cycle because we're disregarding this first term. So the 2022nd number in the cycle, let's divide 2022 divided by 5 because there are 5 digits in the sequence. So you got 4, 0, 4, remainder 2. So because we get a remainder 2, it should be the second term in the cycle, which is 2. So the answer is C. Question number 23. A rectangle with vertices 0, 0, 100, 0, 100, 50, and 0, 50 has a circle with center 75, 30 and radius 10 cut out of it. What is the slope of the line through 75, 30 that divides the remaining area of the rectangle into two equal parts? So let's start with the diagram. So let's draw the rectangle. Like this. And so it starts at 0, 0, 0, 0, 100, 0, 100, 0, 100, 50, 50, and 0, 50, right here. And has a circle with center 75, 30. So 75, 30 we can say is about right there. So this is about 75, 30. 75, 30. And a radius of 10 cut out of it. Though I'm not really sure we need that information. So it says that this line must divide the remaining area of the rectangle into two equal parts. So any line that divides the area of a rectangle into two parts must be the center. And in this case, the center is 50, 25. Furthermore, the line goes through 75, 30. So we can draw a rough sketch of the line, which will look something like this. And as you can sort of tell, this does divide the rectangle into two parts. And now, because we have 2 points, we can find the slope. So let's use the slope formula. So y2 minus y1 divided by x2 minus x1, we get 5 divided by 25 is equal to 1/5. So the answer is A. Question 24 states, when Mike's phone is fully charged, it runs out in 32 hours if he only uses it for phone calls, in 20 hours if he only uses it for the internet, and in 80 hours if he does not use it at all. Mike gets on a train with his phone half charged. While on the train, the time he is on the internet, the time he is making phone calls, and the time he is not using it are all the same. His phone runs out of charge just as the train reaches its destination. How many hours did the train journey take? So let's say, okay, so it says from full battery, it's 32 hours for phone calls. So that's so for phone calls, it's 32 hours, which means this is 1/32 of his battery per hour. So in 1 hour, it's 1/32. And next for the internet, it's 20 hours, which means it's 1/20th in 1 hour. And finally, if he does not use it at all, no use, then it's 80 hours, which means it's 1/80th. These are all for 1 hour. And he uses each of them for the same time t. So let's say the same time t. He uses 1/32 t plus 1/20th t plus 1/80th t. And his phone is half charged when he begins. So each of this added together has to equal 0.5 because his phone is not a full charge, it's at half charge. So we can factor out a t and we get 1/32 plus 1/20th plus 1/80th equal to 0.5. So now we have to add each of these together, in which we get t times, so this is 5/160 plus 8/160 plus 2/160 equals 0.5. So this means t times 15/160 is equal to 0.5. Or actually, we can rewrite this as a fraction just for sake of easiness. So then this is equal to t, or t is equal to 160 divided by 30. So t is equal to 16 by 3. However, as we said before, this t is the same amount of time he spent on each one. So the total amount of time he spent is actually 3t, which is equal to 3 times 16 by 3, which is equal to 16. So our answer is D. Question 25. 7 different single-digit numbers are written in the circles of the diagram shown with one number in each circle. The product of the three numbers in each of the three lines of three numbers is the same. Which number is written in the circle containing the question mark? So this just means that these lines you see here, here, and here, they each have different numbers in the circles, and the products and the lines are equal. So how do we approach this problem? So it says there's 7 single-digit numbers and not the 10 single-digit numbers that are possible. So this is because uh, the numbers 5, 7, and 0 will not work, because if you put 5 in any of these circles, because you can only use it once. So if you put 5 in any of these, then none of the other rows and columns will be equal to the row that has 5 in it. This also applies to 7 and 0. So we can assume that the numbers or digits that are used are 1, 2, 3, 4, 6, 8, and 9. So here are our 7 digits. So how do we figure out where each one is? So let's multiply these numbers out. So 1 times 2 times 3 times 4 times 6 times 8 times 9. And this is equal to so we can split into 2's and 3's. So we have 2 times 3 times 2 squared times 2 times 3, which is 6, times 2 cubed, which is 8, times 3 squared, which is 9. So this is equal to 2 to the power 7, I think. Yeah, 2 to the power 7 times 3 to the power 4. This is the total, oh, 3 to the, let's erase this, 3 to the power 4. So this is the total product. So now we know that for the number in the question mark, it has to be equal to 2 or 8. And the reason that this has to be 2 or 8 is because in these rows, the rows must have perfect squares, and 2 or 8 won't satisfy that condition. But however, the question mark, let's say the question mark is equal to 8. This won't be able to happen, because that means the product of the rest will be 2 to the power 7 times 3 to the power 4 divided by 2 cubed. So this is equal to 2 to the power 4 times 3 to the power 4, which won't be able to work. So, and this won't be able to work because once you take the square root of this, this is equal to 36. And 36 is not divisible by 8. So that means the question mark has to be equal to 2. So your answer is A. Question 26. Arnav drew a closed path on a cuboid and then unfolded it to give a net. Which of the nets shown could not be the net of Arnav's cuboid? So we can sort of trace out each of these cuboids and see which one is closed and which one isn't. So let's start with A. So we can sort of make a dotted path that goes all the way around to here. So this works because it's a closed system or closed path. Now let's do B. So if you do B, then go something like this, and this is also closed. So C is where it gets a little tricky. It's pretty difficult to make a closed system with this or closed path with this because let's say you connect these, then you make this one go all the way around, then it's sort of impossible to connect these other two without going in between, and this won't work. So C isn't a closed path. Let's try the next one. So D, let's connect these two over here, and then we can make a path going around to here, and finally connect these two here. So D also does work. Although it is a little bit complicated, it does work. Now let's try E. So E, it's also pretty straightforward. You would connect these two, and then connect these, and this also works. So C cannot be Arnav's cuboid because it is not a closed path. Question 27 states how many three-digit positive integers x are there such that subtracting the sum of digits of x from x gives a three-digit number whose digits are all the same. So let's say the final, or let's say the three-digit number is x, y, z. Then we have to, let's say the sum of x, y, and z is 100x plus 10y plus z. And from here, we would have to subtract, well, this is what the number would be. And now let's subtract the sum of the digits, x plus y plus z. This gives us 99x plus 9y. As you can see, 11 is a divisor of this value. So because 11, or sorry, not 11, 9 is a divisor of this value, because 9 is a divisor of this value, that means the only three-digit numbers that would work would be 333, 666, and 999. However, 999, it won't work because this means that the the true number, the true integer x, for which you subtract three digits to become 999, this value x would be greater, uh, this value x would be greater than 1000, which would not work because it has to be a three-digit positive integer. So this 999 is not an option, which means that our only choices are between 333 and 666. So let's see 333. So for 333, 11 times value of x plus b has to be equal to 37 because x must be equal to 3. So when x is equal to 3, that means b has to be equal to 4. So because x is equal to 3, b is equal to 4, sorry, not b, I meant to say y. 11x plus y is equal to 37, x is equal to 3, y is equal to 4. This means we have values of z, which is equal to 0, 1, 2, 3, all the way until 9. And this will give us numbers such as 340, 341, 341, 342, all the way until 349. So this gives us 10 values. Now let's look at 666. So this again will be 11x plus y. This time it must be equal to 74 because we have to double what is of 333, so we can solve it, and when x is equal to 6, we get y is equal to 8. So this gives us values of z again, which must be from 0 all the way to 9. So we end up with numbers of 680, 681, 682, all the way until 689. So this again is 10 values. So the 10 values from here plus the 10 values from here makes it 20 values total, which means that the answer is D. Question 28. In how many different ways can the word banana be read from the following table by moving from one cell to another cell with which it shares an edge? So let's draw out these cells, or I can draw a few. So let's put one for B, BA, BAN, BANA, BANAN, finally BANANA. There we go. So now let's copy these tables over. And we can make this one a little bit bigger. Same with this one. Okay, so if we start with B, we'll have 1 in the top left and 0 everywhere else. So since this 1 can move to the each adjacent cell, we'll end up with a 1 here and a 1 in the two adjacent ones over here. Next, when we move to BAN, these ones can move to the adjacent corners, and because both can move to the center, we'll get a 2, leaving the rest filled with zeros. Now, the center in BANA, the center will be 0, while each in the vertical and horizontal row will be 3, and the corners will also be 0. Then, if you're kind of seeing the pattern, in BANAN, the center will become 12, and then this corner here will become 6 each, and then here will be 0, and sorry, no, it will not be 0, it'll be 6, and here will also be 6, while these parts over here are 0. And now, finally, the middle in BANANA, in banana, the center will be 0, while each of these will be 24, 24, 24, 24. Sorry, that's not what I meant to write. It will be, there will not be a 6 here, there will be a 0 here, because there has been a 0 throughout, and it can only move to the adjacent ones, which it shares an edge. So then here, because it's a 0 there, this will be 18 and 18. So now we can say 18 plus 18 plus 24 plus 24. This is equal to 36 plus 48, which is equal to 84, which means the answer is D. Question 29. The diagram shows a map of a park. The park is divided into regions. The number inside each region gives its perimeter in kilometers. What is the outer perimeter of the park? So let's just go around labeling each of these. So let's say this part is A, B, C, D, E, and this is F, G, H, and this middle one here is I. So I'll draw this in with black. So now this A, B, C, D, and E give us the outer perimeter, but it also gives us the value of this blue section, this blue inner perimeter as well. the blue inner perimeter. So that means we must subtract A plus B plus C plus D minus F. So F, G, and H give us the blue perimeter, so we have to subtract F, G, and H, so F plus G plus H. However, as we see, F, G, H also give us this perimeter over here, the perimeter of I, which means that since we are subtracting the perimeter of I, we now have to add the perimeter of I. So this perimeter of the outer is equal to A plus B plus C plus D minus F plus G plus H, and then we finally have to add the perimeter of I. So now we can do perimeter is equal to, so A is equal to 12 plus 6 plus 4 plus 9, or there should also be a plus E in here, plus 11 minus 3 plus 7 plus 10 plus 4. So now this should give a value of, this is 10, 20, 30, so 42 minus 20 plus 4, so this should be 22, 26. So this should be 26 kilometers, which is B. Question 30, the final question. Elizabeth wants to write the integers 1 to 9 in the 9 boxes shown so that the integers in any 3 adjacent boxes add up to a multiple of 3. In how many ways can she do this? So let's say, let's just look at the first 4 integers. Let's say it's A, B, C, and D, the first 4 integers. So when looking at the first 4 integers, that means A plus B plus C must be equal to 3 times some value, let's say K. And then B plus C plus D must also be some, let's say K1 here, and must be multiple of 3, so let's say some value K2. So this also means that A minus D has to be equal to 3, or 3 times some value K, so a multiple of 3. Let's say K3. So this is only the first 4 terms, first 4 digits. This works with any set of, let's say, 1, 4, 7, 2, 5, 8, and 3, 6, 9. So now we have to figure out where each of these 3 sets will go. So we have 3 choices for, well, we have to see where each of these 3 will go. So we have 3 choices for where the first one will go, 2 choices for where the second one will go, and 1 choice for where the third one will go, which is 6 choices total. Also, within the order of each one, we have 3 choices for the first one, times 2 choices for the second, times 1 choice for the third, which is equal to 6. So because we have 6 for each of these, we have 6 cubed times another 6, which is equal to 6 to the power 4. And this is equal to A.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramatricule.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email but without the info and the end. So bye!